Welcome to Engineering Future One. I'm Mr. Weber, and I'll be your teacher this year. Engineering Future One is part of our STEM Academy here at Lakeville South, and we're very excited to have you with us this year. The STEM Academy is part of a national movement that deals in using science, technology, engineering, and math to look at the world differently and help students become better critical thinkers, I think is the simplest way to look at that. We use it as a way to teach students critical thinking, but we also use it as a way to look at real world problems and have students take a shot at trying to figure out solutions. And we do that through project-based learning. So we do a lot of projects. Here at the STEM Academy and in Engineering Future One, we are changing the way students learn, understand, problem solve, and most importantly, think. A lot of students have been able to sit in school and not do a lot of thinking or never been asked to do any original thinking. They follow what the teacher says and only do what the teacher says. But here, it is all about the student individually applying themselves, thinking differently, using those skills to make stuff, design stuff. So Engineering Future One is an introductory course. There's Engineering Future 2, 3, and the capstone, which is part of our STEM Academy. And I'll talk a little bit more about that later. But basically, students are taught to be creators, to be designers, to be builders, to be what we now call makers. This is a maker revolution. With applications like YouTube, you're able to learn how to do stuff. And with technologies that are more individual now, we're allowed to create all types of things. So we're riding what's called the maker revolution right now, and excited for the kids to have the opportunity to do those things. So why this class? We do focus on engineering. That's part of our name. But most importantly, we focus on being creative. We do a lot of collaboration. That'll change a little bit with social distancing, but we'll work through that. We use a lot of cutting edge technologies. We as humans are innately curious, and we love to solve problems. So here, that's what we do. We get up, we move, we apply our skills, we apply the students' creative thinking to their projects, not my ideas. So here, being creative, being curious, and liking to solve problems you're going to enjoy it. As I mentioned, we do a lot of design work here. We love to find innovative solutions that haven't been done before, and we do a lot of building, creating, making. So that's if you like to be hands-on, if you like to get up and be doing, thinking, finding creative solutions, this is going to be the class for you. We as humans learn best by experience. Being told how to do something, you don't really learn it near as well. So here, failure is going to be your friend. You have to be able to fail. And you got to get used to it. Failure is part of life. We fail all the time. Most successful people are those that learn to fail the quickest. And so here we have a motto called fast to failure. So the faster you learn to fail, the faster you learn things about what you're trying to do, the more success you're going to eventually have. So in school, we've taught you to fear that letter grade F. And here, we encourage you to fail as quickly as possible, because then the solutions are going to come. You're going to find different ways to do it, innovative ways to do it, creative ways to do it, and different ways to do it, which is what we need. As I mentioned, we're all hands-on, so we're always up moving. We do a lot of design work, and then you get to use those skills to test and apply and prototype and model to design and build and create. We do use a lot of interesting technologies, state-of-the-art technologies. We have a lot of 3D printers. We have right now we have probably 28 3D printers and more on the way. We have both filament-based printers, which is kind of the traditional ones a lot of people have seen, but we have SLA, which are liquid-based printers, higher-end printers. We have laser engravers, 9 laser engravers that do cutting of material from wood to plexiglass to etching metal. We have a CNC router. We have a plasma cutter, 3D scanners. We use a ton of different CAD programs. CAD stands for computer-aided design. So we do a lot of design work originally from sketching, but then up onto a computer so that it can be moved into a machine and let the machine do the accuracy and the detail work. Being a creative thinker is important here. Being willing to think is important here. The world needs people who think differently, and that's a skill, and we help you develop that skill. You don't just become a creative thinker. You have to practice it like any other skill in the world. And the more you practice it, the better you get, the better you can apply it. So that's a focus here. Learning to think differently and apply your skills and your ideas to problems in unique ways is really what we focus on. The STEM Academy is built for you. It's all about you using equipment, learning to do stuff, applying yourself. There's no formal tests or quizzes, so that we don't study for things per se in the traditional way. We apply our knowledge and we test and prototype and model and learn to do things. And the projects you create are really the demonstration of your knowledge. And we can all do it differently and all have an A because we've created a project that maybe is unique, different, but a successful project. So once you've done that, you're free to create on your own. Once you've learned the machinery, you can create and make and do things that you're passionate about, whether it's skateboarding or music or whatever. So we have students who apply these skills and this knowledge to the things they love to do, and not just the things that we do in class. So the original work is really what we focus on. What we try to do is inspire and motivate students in their area of passion so that they'll go home or even here and work on stuff that interests them, to design and build stuff that is something that they care about. And then they're free to come in and design and build here those same projects. So we have students who have created guitars, designed and built very unique guitars, and done that here. And we have students who have made sports equipment, lacrosse sticks, all types of different things, and designed it here, created it here, used our machinery to do it. So we try to ignite your individual passions and let you use those passions to do whatever you want. Create gifts. A lot of students create gifts here for people once they learn how to use equipment. So it's really a playground for you. That's what we've created, is a place for you to apply and think differently and to make stuff. Some of our units include 3D printing. One of the first things you'll do is you'll 3D print, you'll scan yourself, you'll 3D print your head, as you see in the picture there. You'll mold yourself and you'll make a cardboard model, and then you'll actually pour yourself in chocolate and eat yourself. And the chocolate's really good. So, but if you haven't seen yourself 3D printed, it's pretty sweet. And you'll take that model home, and then you'll be able to make a chocolate head of yourself, and you'll be able to eat yourself. So it gives you an idea of how to use a bunch of different technologies in a very unique and fun and interesting way. We do a lot of work in the medical field because biomedical engineering is a very big and growing occupation right now. So we work on different prosthetics, designs, how they go about that, learning the process of how parts are made. So biomedical engineering is an interesting and wide open field and growing continuously. So another one of our units. We do a lot of work in design, from sketching all the way up to design in CAD. And here's an example of a student that designed a kind of an art form and then laser engraved it onto their jeans. So this is the crossover between many disciplines: art, design, manufacturing, all just because they're interested in. This wasn't a project that we asked them to do. This was something that they just decided they were interested in and wanted to try. Innovation is part of everything we do. All our units involve some type of innovation. Here's an example of a cast that was made to get rid of the heavy, bulky closed cast and make it just as strong, but obviously not hot, sweaty, itchy. If you've had a cast on, you know the difference. So innovation is important. Here's a guitar patterned after the American flag, and UV printed the eagle on there. And that's, a lot of those parts are 3D printed. So again, it's based on passion. Laser engravers are used to cut material out in a very accurate pattern. You can cut wood. So these are different models people make. We do all types of work, from photo etching into wood to laser etching on metal to cutting out parts. So very fun and interesting and cutting edge technology. CAD stands for Computer Aided Design. As I mentioned many times, we do a lot of work on computers to allow for the accuracy and then to allow us to use those files in machinery that, again, are state of the art. So a lot of different CAD files. We move for a lot of programs and a lot of technology. We keep the kids active and applying these skills, not just drawing and never having a chance to ever use those skills to make something. So it's all about the end product, getting something made in unique and creative ways. A great example, here's a student that we mentioned something to, and they created a 3D printed record. It actually does play. It's very interesting. But again, when you look at the process, very unique and original things that people normally wouldn't think of. We do a lot with electronics, makey-makeys, Arduinos, different types of circuits and circuit design. So again, you don't need to understand how to use a 3D printer. You don't need to know about electronic circuits. In fact, knowing nothing is great. That's why you should be in this class. It's a great way to learn about stuff in a fun and interesting and exciting way. And it might inspire you to learn more. That's kind of our hope. So a lot of these units, if you know nothing about them, outstanding. Okay? If you've never used equipment before, outstanding. This is the place. We're excited to have you. And as I mentioned, trial and error and learning to fail, that's how we all do it. That's how I've learned to do it. So I'm excited to have you here. We have units in robotics. We learn to code, both written code and block coding. We actually, in like an Engineering Future 3, if you continue on in the STEM Academy, you'll design and make a walking robot. So robotics is, again, a very up-and-coming area in our society, and we try to at least introduce you to the area of understanding. I'm going to leave by having you take a look at the screen. This is a picture of a prosthetic hand, 3D printed. If you look at the one laying down, you see there's a watch built right into the back of the hand, and that actually has a little compartment, a door that opens up to put stuff in. And so people would ask, why would you put a watch on there? And why would you make a door in there? And the answer is, why not? And that's the way you got to look at things in here. Why not do it? Why would you not make the hand more functional than it is when it was normally there? So if you're going to make something new, being creative and different makes the world an interesting place and comes up with the best solutions. So I'm excited to have you. I'm excited to see you here, and I think you're really going to enjoy this change of pace. It's totally different from traditional high school. So I look forward to seeing you. Thanks.